Hello, everybody, and thank you for tuning in. My name is Ashley Messier, and today I will be discussing the role of vegetation phenology metrics in the nest site selection of a declining prairie grouse, the lesser prairie chicken. Vegetation phenology metrics give us information about the growing patterns of living vegetation in a given season. So, for example, this could be the start and end of the growing season, the duration of the growing season, among many others. Now, all of these metrics are derived from the Normalized Difference Vegetation Index, or NDVI. This is a remotely sensed index that measures the difference between the amount of near-infrared and red light being reflected off of living vegetation. And this equation can be seen right here. NDVI is often used as a proxy for vegetation productivity or greenness, but it can also tell us a lot about the health and vigor of living vegetation. Now, NDVI has been used in ecological studies for many decades and has been linked to habitat quality and availability for a number of species. It is because of these historic successes, as well as the continuing declines of many grassland species, that its utility moving forward is of interest. So, for example, the lesser prairie chicken is an at-risk grassland obligate that relies on healthy, intact grasslands to reproduce. As such, it is important to know what's available to them across their range from a reproductive habitat perspective. Unfortunately, it is very difficult to monitor this species at those relevant spatial scales across their range, and that's in part due to the vast expanse of private land ownership across the Great Plains across their range. So it is because of this that we believe that remote sensing and NDVI may be a useful tool in evaluating the quality and availability of lesser prairie chicken reproductive habitat at broad spatial scales. The lesser prairie chicken range spans 5 states and 4 different ecoregions across the Great Plains. But for this research, data was collected in 5 counties in western Kansas. So we have Logan, Gove, Clark, Kiowa, and Comanche. And each of these study sites, as you can see, falls within a portion of the current estimated range of the lesser prairie chicken. So my objectives were to evaluate whether snapshot NDVI or associated phenology metrics are reliable predictors of lesser prairie chicken nest site selection. Now, snapshot NDVI is just NDVI at the nest site at the time it was initiated. So it's like looking at NDVI in real time. In order to address these objectives, I needed both physical and remotely sensed data. My physical data came from female lesser prairie chickens that were captured in 2013 and 2014, all of which were marked with VHF or GPS transmitters. Once a nest had either hatched or failed, that nest was visited and vegetation data was collected. We had a sample size of 69 nests, and at each of those nests, the measurements collected included the most dominant species in a 4-meter circle around the nest, Daubenmeier-related measurements at the nest, visual obstruction readings, and importantly, the initiation date of the nest, so when the female started her nest. My remotely sensed data included the collection of satellite images from 2 different satellites. So in order to evaluate the snapshot NDVI, so the NDVI at the nest site at the time it was initiated, I downloaded satellite images that were cloud-free from the Landsat 8 Level 2 OLI/TERS satellite. Now, each of these images corresponded to the initiation date of each nest, and they were delivered at a 30-meter pixel resolution. So each pixel in these images represented 30 meters on the ground. Now, in order to evaluate the phenology metrics at all of my nest sites, I downloaded yearly AQUA MODIS RSP, which stands for Remote Sensing Phenology images, and these are delivered at 250-meter pixel resolution. So each pixel represents 250 meters on the ground. What's important to note about these AQUA MODIS images is that they are a time series. So there is 1 image per phenology metric per year. And these different phenology metrics can be seen over here in table 1. So we have, for example, the start of the growing season, like the date of the growing season, as well as the NDVI value at the start of the growing season, and so on and so forth. So these images are already pre-calculated. Every phenology metric is already analyzed. Now, using ArcGIS, I placed 3.2 kilometer buffers around each of my nests in each satellite image. I also generated 2 random points within each buffer. In the Landsat 8 images, I manually calculated NDVI, and then I extracted those NDVI values. And similarly, for the phenology metrics, I was able to bring into ArcGIS all of my nests and I was able to extract the phenology metrics from those points as well. Following this, I developed two candidate model sets. I had a snapshot NDVI model set and a phenology model set. I used an information theoretic approach and generalized linear models, specifically logistic regressions. So before we move on to the results, I wanted to show you an example of a Landsat 8 snapshot NDVI image, as well as an AQUA MODIS remote sensing phenology image. So on the left here, we have a snapshot NDVI image. This is a nest in Clark County, Kansas. You can see the buffer, the two random points, and the nest point. And this was calculated on, as you can see down here, May 3rd, 2014. So this is one specific day. This is NDVI on that day. On the right here, this is an amplitude phenology metric image. So this is amplitude across an entire year. And you can see these nests here, how I was able to bring all of them in and just extract the values because this was just amplitude for the year, for the growing season. So for my results, my snapshot NDVI model set, unfortunately, we see here that snapshot NDVI did not appear to be a reliable predictor of lesser prairie chicken nest site selection. So none of these models outcompeted the null model as the beta coefficients overlap 0. And similarly, with the phenology model set, we have multiple single variable models that were within 2 delta AICC of the null model. But again, as we saw with the snapshot NDVI model set, all of these beta coefficients overlap 0 at the 95% confidence interval. And as such, no model outcompeted the null model. And so phenology metrics alone do not appear to be reliable predictors of lesser prairie chicken nest site selection. This figure here is just to show from the snapshot NDVI model, probability of use as a function of NDVI. Looking at this, it appeared as though probability of use was optimized in the 0.2 to 0.3 range. But again, this was not significant. And again, the null model was the top model. Similarly, this is from the phenology model set. This is showing probability of use as a function of maximum NDVI, where probability of use appeared to increase as maximum NDVI increased. But again, this was not significant, and the null model remains the top model. So it's important to remember that these are preliminary results, and that based on these analyses, these preliminary analyses, snapshot NDVI and phenology metrics alone are not reliable predictors of lesser prairie chicken nest site selection. So there may be interactions between climate and disturbance variables, but I have not yet examined any of these variables, though I do plan to in the next steps of this research. So as I just mentioned, my next steps include incorporating not only those disturbance and climatic variables, but also more nest and brood data from across the lesser prairie chicken range. So with that being said, I would like to thank the Horticulture and Natural Resources Department at Kansas State University, all of the private landowners that allowed this data and research to be collected on their land, and similarly, the technicians and graduate students that spent a lot of time assisting in data collection, again, across the lesser prairie chicken range. Lastly, I would like to thank the U.S. Fish and Wildlife Service and the U.S. Geological Survey and the Kansas Cooperative Fish and Wildlife Research Unit for their financial and logistic support in this research and in the research moving forward. Thank you very much.